Now I'm professional. Once that bing goes off, I have to be a professional. Today we are talking about solving quadratics, which is what we've been talking about, right? By using square roots. By using square roots. Now, we have been talking about quadratics of the form. Ooh, look, I didn't put myself in the video. Hold on, I'm going to slide me over there. Oh, way off in the corner, so I only have to see me a little bit. So we've been talking about square roots of the variety ax squared plus bx plus c, right? That should look familiar to everybody. If it doesn't, go back and watch the last few videos, refresh yourself. But what we're talking about now is what we can do when we don't have that bx term. So if I have something of the form ax plus c or just ax squared, right, and I don't have that bx term, we can solve these using square roots. Now, I see you guys are still being chatty in the chat box over there, but you better be paying attention as well. Okay. You can multitask? I hope so. So anything of this form, remember these all equal 0. I didn't set the equal 0. So we can use these of the if x squared equals n, which is like any number, right? Something. Then x equals plus or minus the square root of n. And you guys probably remember that if I had something that was like x squared equals 4 back in the day, you could just take the square root of both sides, right? And you would get x equals, well, what would you get? If I asked you what the square root of 4 was, what would you tell me? Shaylin says 2. Does anyone agree with her? Does anyone else think 2? Everybody should agree with her, right? 2 times 2 is 4, so the square root of 4 is 2. But get this. Negative 2 times negative 2 also equals 4. So the answer is actually plus or minus 2, because it can be negative 2 or it can be positive 2. And when we're dealing with squares, you'll always have 2 answers. You will have a plus and you will have a minus. And as we get into higher maths, we can't neglect that negative anymore, right? Which is what we did when we were younger, because we didn't understand integers. When we first learned about square roots, we didn't know about integers. We didn't understand negative numbers. But now we know that a negative times a negative equals a positive. So to get 4, we can either multiply negative 2 times negative 2 or 2 times 2. So we have to acknowledge both of those answers, both of those solutions. There are steps that we can take when we're using square roots to solve quadratics. Number 1, I always like to make my first step number 1 because, well, it would be weird to make it number 3. Number 1 would be isolate x squared. That means we want x squared, or whatever variable it is that's squared, to be the only thing on one side of the equal sign. Number 2, because logically it follows number 1, we want to take the square root of both sides. Number 3, we are going to simplify the radical. Do you know what the radical is? I put my period in a very weird place. We're going to simplify the radical, and then we're going to put plus and minus in front of our solution, right? This right here is the radical. Whatever is underneath it, this blah, 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 is the radicand. The little symbol, though, that you see that looks like a division sign, but with an extra line on it, that's considered a radical. I might have that backwards, but who cares? One of them's the radical, one of them's the radicand, but we got to simplify it. That means we've got to take as much as we can out of it. Here, just as a little reminder, let's look at what our perfect squares are. We've got 1 squared equals 1. 2 squared equals 4, 3 squared equals 9, 4 squared equals 16, 5 squared equals 25, 6 squared equals 36, 7 squared equals 49, 8 squared equals 64, 9 squared equals 81, 10 squared equals 100, 11 squared equals 121, 12 squared equals 144, 13 squared equals 169, 14 squared equals 196, 15 squared equals 225. Those are all the ones I know in my head. So that's as long a list as you're getting. But it helps to know those things. It helps to be able to look at them and go, well, what times what equals what, right? So that I could tell if I have a perfect square. Normally, they're not going to get much bigger than this. So if you know them up to 15, it's really convenient for you. But if you don't know them up to 15, you could still do this, right? Because you are all smart. When you go to do this worksheet, there are some things you need to know. 1, do not give me decimals. Do not stick this into a calculator and give me some decimal answer. I will put a 0 on your paper and tell you to do it again, right? Because I don't care if a calculator knows how to take a square root, right? The whole idea of being able to do this is sometimes we have to be able to plug this math into something else. And if you aren't giving it to me in the proper form, it isn't going to fit well into what we need it for down the road, right? So fractions are important and square roots are important when we're talking about higher maths, because we have to be able to plug them in and out of things. And if you just put in your calculator answer in decimal form, they become kind of unusable. Especially if those decimals get super long and you're cutting corners with all of that. So let's look at some simple stuff. I think the best way to teach this is to show you just a bunch of examples. And so that is what I'm going to do. And I'm going to start with easy examples and get more complicated as we go. I'm going to start with x squared minus 64 equals 0. And for those of you who are in the last lesson, you would recognize this as a difference of squares. And yeah, you could do that to solve it. But because we're specifically doing use square roots to solve these problems, we're going to follow the steps by isolating x squared first. And the only thing attached to this x squared is 64, right? We have 64 being subtracted. So I'm just going to add 64 to both sides of the equal sign to keep it equal. And I'm going to have x squared equals 64. Now that allows me to take the square root of both sides. right? We're going to take the square root of x squared and the square root of 64. When I take the square root of x squared, I'm left with x. When I take the square root of 64, I am left with, if you look at 64, well, we know it's a perfect square because right here it's 8 squared. So we could just actually pull that out as plus or minus 8. But if you don't know that, we can break it down, right? If you really don't know anything about it other than it's an even number, you could do it as 2 times 32, right? And then you go, well, 32 is an even number. Well, that's 2 times 2 times 16. And if you don't know, that's a perfect, like you could break this all the way down if you want to. Like sometimes when I'm teaching it, I will look at it like, sorry, we don't want to start with 32. We want to start with 64. Sometimes I'll start it like, okay, well, that's 2 times 32. And that's 2 times 16. And that's 2 times 8. And that's 2 times 4. And that is 2 times 2. And what are we talking about when we look at perfect squares? When we're talking about squares, it means what pairs of something can I pull out? What pairs of factors? Well, here I can pull out one set of 2's, another set of 2's, another set of 2's, right? I feel like I got too many there. 2's, 2's, 2's. No, that's right. 2 times 2 is 4 times 2 is 8, right? And so each one of these 2's can be pulled out. So I would be left with 2 times 2 times 2, which is plus or minus 8. And I know that that was an ultra confusing way of doing it, but I kind of want you to see what squares are, right? We're saying that it's 8 times 8. How do I know that? Because, well, 8 times 8 is 64, right? But it isn't, we're not always going to have a perfect square, so you need to know how to break them down because you have to be able to pull the perfect squares out and leave the rest behind. So now that I made that really simple problem complicated, let's go back to doing it a little bit more simply. What if I have 7x squared plus 8 equals 15? When we're going to do that isolating x squared, we're going to get everything that's on that x squared and move it to the other side. So we're going to start by subtracting 8. No, you don't have to do it in the format we just did. That was just an example so that you can kind of see how it breaks down. So when I subtract that 8, I get 7x squared equals 7. Now we're going to divide, boom, by 7. And we've got x squared equals 1. So when I take the square root of both sides, your gift for me complicating that last problem was to give you this nice, easy one, right? So when we take the square root of both sides of this, we are left with x equals plus or minus the square root of 1. But what is the square root of 1? What times itself equals 1? Did I stump you with that question? Because I'm like, it's such an easy question. I stumped everybody. Yeah, 1, right? The only thing that times itself that equals 1 is 1. And so we just get x equals plus or minus 1. That is our solution. That is as far as we need to take it. Notice that it is 2 answers. It is positive 1 and it's negative 1. And that'll come in really handy when we get into the quadratic formula. Because if you remember with quadratics, a lot of times we have 2 solutions, right? Most of the time we have 2 solutions. What if I have, I like this one. This one's interesting. What if I have 81x squared plus 5 equals 21? I like this one because it's going to give us a fraction to break down in the end. So here I got to start working on what's being done to x and start undoing it. And so I'm going to start by subtracting this 5 from both sides, which gives me 81 x squared equals 16, right? 21 minus 5 is 16. Now we're going to divide out that 81 that's being multiplied to our x squared, right? And we get x squared equals this fraction, 16 over 81. So when I go to take the square root of both sides, boom, boom, I'm left with x equals this 16 over 81. And one of the reasons I really wanted to use this is because sometimes people don't understand how you would break down a fraction in a square root, right? If I have a fraction under the square root, I could rewrite this as the square root of 16 over the square root of 81. Now, lucky for us, these are both perfect squares, right? 16 is 4 times 4. 81 is 9 times 9. But when I go to solve this, I'm going to go, well, what's the square root of 16? Well, it's 4. Over what's the square root of 81? That's 9. And this is our solution, right? But I really wanted you to see how a fraction would break down when you take the square root. It's basically you take the square root of the top over the square root of the bottom. Are they always going to be perfect squares? No. Which is what we're going to move into now. What happens when our squares aren't perfect? We throw them out, just like our children. Just kidding. If our squares aren't perfect, we just do the best we can with them. That's more just like our children. 2x squared minus 9 equals 55. Well, we're going to start doing just like we did before. We're going to get that x squared all by itself. So here I'm going to add 9 to both sides, and I will get 2x squared equals 64. And you're like, hey, Miss Hoy, that's looking good. 64 is a perfect square. But we're not done yet. We don't have that x squared by itself. We got to divide this by 2. And I am left with x squared equals 32. And our next step is, oh yeah, we got to take the square root of both sides, which gives me x, not x squared. The whole reason is to get rid of that squared. And there I go, writing it again. X equals, well, plus or minus the square root of 32. But 32 is not a perfect square, right? But it's got a perfect square in it. We have to look at the factors of 32 and see if we can pull a perfect square out. Now, technically, when I look at 32, like I could look at 32 as 2 times 16, right? And I know that 16 is a perfect square, right? But what if I didn't know that? What if I wasn't altogether that brilliant, right? Because, you know, it takes a mastermind to understand that 4 times 4 equals 16, right? But what if I didn't? What if I did not have that mastermind and I needed to figure it out? Well, I could even break it down more if I wanted, right? Like if I know at this point that 16 is a perfect square, I can pull that out right now. But if I don't, I can break it down more. I could go, well, that's 2 times 8. And I know that that would be 2 times 2 times 2 times 4, which is also 2 times 2. Right? I can break it down to its basis form and go, well, I got a pair of 2's here. So that part's a perfect square and that part's a perfect square. And I could pull those out as 4, but I'd still have 1 left and that would have to stay. Or I could use the little cheat sheet I gave you up there where I showed you all the perfect squares, right? And I could look at this first one when I divided by 2, And I go, oh, 16 is a perfect square. It's 4 times 4, right? And I could write this as 4 radical 2, plus or minus, right? Whatever can't be pulled out in the form of a perfect square has to stay under the radicand, the radical. It is the radicand. The number is the radicand. The symbol is the radical. So when I look at this right here, I wind up with x equals plus or minus 4 radical 2. Is that my final answer? Heck yeah, it is. You know how I know? Because there's a box around it. That's my joke always, is that I say my tombstone's going to say, we know she's done, because there's a box around her. Little math teacher humor. Very little. Let's look at another one. Why? Because I like doing this. I just do. Madison gave me an oh Lord on that, but you know it was funny. You know it was funny. I think this will be my last example. Maybe. I don't know. What if I have 9x squared plus 3 equals 111? You're like, whoa, those are some big numbers, Miss Hoy, but not for you. We know you can handle it. We're going to start by subtracting 3 from both sides. And we are going to get 9x squared equals 108. Right? Next, we're going to divide out that 9 because we're trying to get that x squared all by itself. So we have to remove that 9 that is being multiplied to it. And we wind up with x squared equals 12. How do I know that? Because I just did this problem last period. I don't ever remember my 12 times tables. But 9 times 12 is 108. So 108 divided by 12 by 9 would be 12, right? And so now we're going to take the square root of both sides because that's what we've been doing, right? When I take the square root of this side and the square root of this side, I'm left with x equals plus or minus the square root of 12. But what do I know 12 to be? 12 is 3 times 4, right? 4 is a perfect square. Oh, where did everything go? Did you see that? That was super weird. So I'm going to end up with plus or minus. When I pull the 4 out, it becomes 2, right? It's 2 times 2. But that 3 can't come out. Plus or minus 2 radical 3. This is my answer. So what happens if you're doing it and this is as far as you get? I'm going to publicly humiliate you. That's what's going to happen. I will mock you in front of everybody else. No. Like you might lose a point or something. Like if here's an extreme, this is an example of why it's important for you to show work like when we do tests. Because yeah, on your homework, you might just be wrong. But Delta Math, you can keep going until you're 100% right. On a test, if you put it in like the square root of 12, it'd be wrong on Delta Math. Because Delta Math can only give me, this is your right answer, this is your wrong answer, right? So only options, you either get 10 points or 0 points on Delta Math when you're taking a test. But that is why you submit the work for a test, because where Delta Math would give you a 0 for this, I would give you a 9 out of 10. And if you don't submit the work when you do it, all I can give you is a 0, right? So you lose 9 points on something you know how to do all the way up to the end, but just get that little bit wrong, right? So keep that in mind. For those of you who chose not to submit your work on that last test that we had, it can only benefit you. It's not going to hurt you, right? I'm not going to go back and look at ones that you got right and say, but their math is off on this one. You know what I mean? But if you don't show me the work, I have no choice but to give you whatever you got on Delta Math. So keep that in mind. Know how to at least get this far, right? Hopefully you can get all the way to the end, but if you can get this far, you're still going to get most of the points because I can see that you understand the problem, right? You just didn't break it all the way down. I'm not going to do anymore because this class is over in like 3 minutes and we got super chatty early. So we got a little late start in the lesson, but we got just as far as my other class. Your homework is posted in PowerSchool. I haven't put in a hand-in tab yet in the assignment thing, but I'm sure none of you will finish it in the next hour. I don't expect you all to just go running to it. But the worksheet is posted. You only have to do the even ones. I chose the even ones on purpose, so don't do the odd ones because it has one fraction problem in it, and I want to see how you handle it. Show your work. Do not give me decimals. Do not give me a calculator answer, or I will just give you a 0 because you're not doing the work. The calculator is. I want to see that you get it. Jacob, you are free, man. You can go eat now. Go get some food in your belly. I'm going to stop recording because the world doesn't need to hear all this.